I want to show you an example of how an image is stored on disk. So store on disk. So I will create an image of only 2 by 2 pixels. Okay, here we have a very thin image. This is all black. I'm going to find something here, here, and here. We have a set of squares. I will save it. Sorry, I need to export it using BMP. With default data. Okay, so we have here the contents of the image. If we open it using the hexadecimal editor, we can see here the contents of the file. We have a header. All images have a header indicating this is the format of the file, some additional content like the number of bits used by pixel, the size of the image, and things like that. And the real data of our image starts here. Those are the pixels of the image. Remember that each pixel has a value. Then in this case, we are using the RGB model. The bytes are stored as BGR. They are reverted. So this is the content of our first pixel. The pixels on BMP go that way. So this is the first pixel, the second pixel, the third pixel, and the fourth pixel. And the first pixel, here you can see FF. So this will be white because it has all the blue, all the green, and all the red. The second pixel is this one. It's a black pixel, so no red, no blue, no green, no red. And here we have 2 bytes of padding. This is something related to BMP format. And then our next pixel, a black one. This is the black one. And the last pixel, a white one, and another 2 bytes of padding. And if we modify the contents of the file, we will be modifying the image. For example, if we want to convert the second pixel from black to green, we can put an F. We can write an FF here, save the image, open it again with the editor, and here we can see that we have modified the image and we have a green pixel here. Remember that when we were recording sound, storing sounds, they took a lot of space. It happens the same with images, and the problem is worse because we are working in 2 dimensions. So if we have a lot of pixels, an image could take a lot of space on the disk. So we can use the same tricks we use for sound. We can compress the image without loss. We can compress the image with loss, and those are the formats that you have here: JPG, PNG. Those are formats with loss. That the same as the sound they use is mathematical functions and some tricks to reduce the size of the file. So if I record this file using a compressed format, JPG, for example, I can see here, well, that in this case, it takes much more size on the disk because it's a very tiny image. It's only 2 by 2, and compressing something has some overhead that is not compensated here for such a small image. So that's it how an image is stored on the disk. And we open the JPG. We won't be able to see the pixels here because you need to perform very complex operations to rebuild the image from this data.